It would be arrogant to think otherwise, that we are alone, that we are unique and special. Especially if you read the news every day, we are not the pinnacle of creation.
Harvard and NASA have just released new data about 3I Atlas, the third interstellar object ever recorded. Only a few weeks ago, observations showed that 3I Atlas had a very smooth orbit, as if it was only designed to skim past, causing no harm to any planets in the solar system. But recently, when a group of major telescopes like Hubble, Webb, Spherex, and TESS observed it more closely, unusual signs began to appear. The behavior of 3I Atlas seemed more strange compared to the initial calculations. The new numbers, the newly updated trajectories, show that it could come extremely close or even directly collide with Mars. From a distant stranger, 3I Atlas was quickly considered a potential threat that could come close, something that had almost been ruled out before. Many questions are now being raised. Is this a natural cosmic phenomenon or the first evidence of extraterrestrial technology? Why do scientists have to consider this extraordinary possibility? And what NASA and Harvard actually hold in their data will make you rethink everything you ever thought you knew about the universe. On July 1, 2025, a faint point of light appeared in the night sky through the Atlas system in Hawaii and Chile. At first, it was just a tiny dot, no different from the thousands of space objects detected every year. But once the data was compared, its orbit clearly didn't match any asteroid in the solar system. The path looked like a straight cut, not curving around the sun. Astronomers quickly realized this was an interstellar object, later named 3I Atlas, the third ever to visit us after Oumuamua in 2017 and Borisov in 2019. NASA soon confirmed the find, and Harvard joined the analysis. Other telescopes, including Pan-STARRS, Gemini South, and a South African network, added observations. The results sparked intense interest. 3I Atlas was racing nearly 87 kilometers per second relative to Mars. This was not a random object's speed, but the signature of a traveler from the dark void between stars. At first, predictions seemed reassuring. Scientists calculated that 3I Atlas would skim past, staying far enough to avoid danger, even to Mars with its active probes. But the universe is never predictable. With new data and refined calculations, that safety began to slip. A study by Professor Avi Loeb of Harvard showed the closest approach, the MOID or minimum orbit intersection distance, could be just 1.95 to 2.7 million kilometers. That may sound far, but in astronomy it is dangerously close. A small error in measurement or the tug of nearby planets could alter its path. To picture it, think of Mars's orbit as a vast highway. 3I Atlas is speeding along at 300,000 kilometers per hour, and that 1.95 million kilometer gap is like a giant truck roaring past the roadside. A slight deviation or a nudge from gravity could send it straight into collision. From harmless, the story had turned into real concern. What would happen if this impact scenario became reality? Scientists compare such a collision to detonating thousands of nuclear bombs at once. At speeds of over 80 kilometers per second, the energy released as 3I Atlas slammed into Mars would carve out a crater at least 60 kilometers wide, several kilometers deep, leaving a permanent scar on the red planet's surface. The destruction would not stop at the ground. The ejected dust and rock would choke Mars's fragile atmosphere, plunging the planet into darkness for decades. The danger is greater because Mars is not an empty planet. Humanity has already sent numerous exploration missions: Curiosity, Perseverance, Insight. In orbit, satellites like the Mars Reconnaissance Orbiter and MAVEN play crucial roles in observation. A strike from 3I Atlas would wipe out all these achievements. Every rover, every probe, every bit of data currently being gathered could be buried in an instant. The European Space Agency announced October 3, 2025 as the date of closest approach. Current estimates place 3I Atlas about 30 million kilometers from Mars. Though not certain to strike, the tightening orbit has already forced teams worldwide to track it with every tool. From Earth, Hubble and James Webb will watch. On Mars, orbiters like the Mars Reconnaissance Orbiter with high-rise cameras stand ready to observe. That is why Harvard and NASA issued warnings. Even with a low probability, impact cannot be ruled out, and with something capable of reshaping an entire planet, low chance is still far too high. From a faint dot in the night sky, 3I Atlas has become the center of global science. It reminds us the universe is never still, and at any moment, staggering surprises can appear, forcing us to face questions we never imagined. This time, the question is not just whether it will collide, but what exactly are we looking at? As soon as 3I Atlas was discovered, astronomers noticed the first and most striking detail. It did not move like a normal comet. Its path didn't curve toward the sun as many others do, but instead followed a straight, rigid track. It was on a hyperbolic orbit, which meant it wasn't being pulled back to circle the solar system. It was just passing through, destined to leave forever. Traditional comets usually feel the sun's gravity so strongly that their orbits bend when they come close. But 3I Atlas showed an almost stubborn persistence, keeping its course unbent. Even as it entered the solar system, it held its velocity and trajectory with only minor changes from the pull of nearby planets. It was like watching a traveler on a road who refuses to slow down or turn, no matter how crowded the path becomes. Every time new data came in and orbital models were updated, the mystery only deepened. Measurements from Atlas, Hubble, and SphereX showed that 3I Atlas was active, releasing gas and dust. It carried a visible coma, and its carbon dioxide levels were far higher than normal compared to many other comets. These details forced scientists to ask whether its path was being influenced by something more than just classical gravity. Professor Avi Loeb and his team suggested that non-gravitational forces might be at play, and these weren't just tiny light effects. They were measurable deviations that made pure gravity-based orbital models break down. The rates of dust release, bursts of gas, and the size of particles being ejected could all provide small pushes. On their own, each push was minor, but over time they added up, shifting the comet's path in ways no one had expected. Even more puzzling were the pre-discovery observations from TESS. They showed that 3I Atlas was active from a great distance, still many astronomical units from the Sun, at a stage when most comets remain quiet. That suggested that these non-gravitational forces had started acting very early, not just when the Sun's heat usually wakes a comet. Taken together, all of this painted a disturbing picture. The orbit of 3I Atlas wasn't just the default track of a natural body under gravity. It looked like a path being nudged, adjusted, maybe even steered. It didn't feel entirely free. It was as if some outside force was partly guiding its journey, leaving scientists with more questions than answers. And it is exactly because of this strange orbit and because of the visible non-gravitational activity that 3I Atlas is no longer just another comet. It has become an interstellar object marked by forces no one has fully explained. That is why Harvard and NASA began issuing warnings, because even if the chances are slim, those deviations could be enough to bring it dangerously close to Mars, and that is no longer something the world can afford to ignore. The new data about 3I Atlas is not only strange in its orbit. What telescopes recorded about its cometary activity, the emission of gas, dust, and the brightness of the coma surrounding the object makes it unlike any comet ever seen before. One of the most important discoveries came from the James Webb Space Telescope. when 3I Atlas was about 3.32 astronomical units from the Sun, Webb measured the carbon dioxide to water ratio in its coma as 8:1, meaning CO2 was 8 times more abundant than water. This ratio was far beyond the normal range predicted for comets at such distances. SphereX added more details, detecting water ice in the nucleus, but showing the coma dominated by CO2, with emissions growing stronger as 3I Atlas approached. Its CO2 release rate was estimated at 9.4 times 10 to the 26th molecules per second, unusually high for an interstellar object still so far from the Sun. Other signals deepened the mystery. Space.com reported its tail was developing faster than expected, while the coma brightened and expanded dramatically. Its dust composition and reddish tint suggested a mix of water, ice, and CO2, but arranged in a way that did not fit the standard comet model. There was also talk of a 17-minute gas release cycle. This detail may be speculation or rumor, but if true, it would be extraordinary. Natural comets vent gas irregularly, triggered by surface cracks, sunlight, or random heating. They do not release gas on a perfect clock. If 3I Atlas really vented on a 17-minute rhythm, it might hint at internal regulation, even a propulsion-like mechanism distributing gas and heat with precision. Even without that cycle, the proven features alone are striking. A CO2-heavy coma, activity from far beyond the Sun, unexpected brightness, and a complex mix of ice and dust all suggest something unusual. They don't prove it is artificial, but they challenge the idea of a normal comet. The big question is whether 3I Atlas is a natural body with extreme properties, or something disguised, perhaps even a sophisticated artifact from another civilization. If the 17-minute hypothesis is ever confirmed, it could mark the first evidence of an interstellar object using controlled thrust to guide its path, something astronomy has never directly observed. At the same time, scientists remind us there are natural explanations. The high CO2 to water ratio could mean 3I Atlas formed near the CO2 frost line of its original star system. Or it could mean its crust is thick and insulative, trapping water while letting CO2 escape more freely. Still, the suspicion is real because the data is real. The CO2/H2O numbers, the expanding coma, the unusual dust and ice composition, all have been confirmed by NASA, SphereX, James Webb Space Telescope, and reported in ARX-IV studies. The unverified gas cycle may remain only a hypothesis, but even as a possibility, it makes the story more compelling. So the puzzle grows larger. If 3I Atlas is not a comet in the sense we understand, then what exactly is it? An anomaly of nature, or the first interstellar object that carries the fingerprints of technology? From the very first days of observation, 3I Atlas was already puzzling, but when telescopes began to analyze its spectrum, the confusion turned into real bewilderment. Measurements from ESO's Very Large Telescope detected a clear signal of nickel atoms in the coma surrounding the object. What shocked scientists was that nickel appeared strongly, while iron, usually present alongside nickel in natural celestial bodies, was almost absent.
Burning heat up more and more and burst into spectacular flames.
This was not a random detail but an abnormal sign. In most comets, the ratio of nickel to iron is balanced, rarely diverging to such an extreme. The James Webb Telescope further reinforced the suspicion. Its infrared data revealed that the coma of 3I Atlas was not only rich in CO2, but also showed a deep red spectrum, similar to some D-type asteroids. Such bodies often contain carbonized material and dark dust, but this still could not explain why nickel emissions surged so strongly as 3I Atlas moved closer. Harvard, through Professor Avi Loeb, called this a phenomenon outside the boundaries of conventional astrophysics. He emphasized that the lack of iron alongside strong nickel signals was difficult to explain with natural comet formation models. the big question was raised immediately. Does the core of 3I Atlas contain some kind of alloy? If so, it would be an extremely unusual situation. Ordinary comets are made of ice, rocky dust, and volatile gases. The presence of a pure alloy, especially one rich in nickel but lacking iron, would push this object outside the category of natural bodies we have ever known. One hypothesis being discussed is that the core of 3I Atlas could be an artificial structure. In human technology, nickel is commonly used to produce alloys resistant to corrosion and capable of withstanding high temperatures. Seeing nickel without iron is reminiscent of refined metallurgy, where metals are separated with high precision, an artificial process normally found only in industry and one that is very difficult to imagine occurring naturally in an interstellar comet. If this scenario is true, it carries a frightening twist. 3I Atlas might not just be a wandering ball of ice and dust, but a deliberately built structure, some kind of machine or device covered in an artificial shell. If it approaches Mars, the possibility of impact would not just mean a crater, but the release of colossal energy from its metallic core. Of course, not everyone agrees. Some cautious scientists argue that 3I Atlas could have formed in a different environment where nickel condensed more easily than iron. Or its outer layers may have been eroded over millions of years, exposing a region richer in nickel than usual. But so far, no model has convincingly explained this strange metallic imbalance. What is certain is that 3I Atlas has challenged the limits of current astronomy. If its mysterious metal core is real, this would be powerful evidence that we are facing something unlike any comet before. And when Harvard insists that this phenomenon lies beyond conventional astrophysics, the scenario of an artificial product is no longer just imagination. It has become a serious question humanity must confront. As 3I Atlas continues to close in on Mars, that question grows more urgent. Are we observing an extraordinarily strange natural body, or are we for the first time witnessing extraterrestrial technology enter the sight of humankind? While scientists are still debating the nature of the mysterious metallic core of 3I Atlas, a startling piece of information began to spread. Mars Express, ESA's satellite orbiting Mars, was said to have sent back images of at least 3 shiny triangular objects in the high orbit of the red planet. According to reports, these 3 objects appeared in 3 relatively fixed positions over 3 consecutive orbits, as if they were maintaining a stable formation. This pushed the story to an entirely new level. It was no longer just about 3I Atlas approaching Mars, but the possibility that it had already deployed auxiliary structures around the planet. The idea sounds like science fiction, but those spreading the information insist that the triangular shapes, the unchanging relative positions to the Martian surface, and the unusual brightness in the images all suggest these objects may not be natural debris. The speculation goes further. They could be probes released by 3I Atlas as it neared the planet, or devices meant to observe, to prepare for a descent, or at the very least, to collect data during the approach. The hypothesis that auxiliary objects might separate from 3I Atlas is not baseless if we look at the real data already discussed: gas emissions, periodic or oddly oriented venting, the metallic core. If 3I Atlas has a complex structure, then releasing probes, auxiliary modules, or observation devices as it nears a target planet could be part of its operating mechanism. This is a simulation, not a scientific conclusion. If true, the presence of triangular objects would greatly increase the threat. They could affect orbit and gravitational dynamics. In the event of a collision or close encounter, these auxiliaries might scatter into fragments, dust, or even crash into human satellites around Mars, or worse, interfere with exploration equipment on the surface. The seriousness becomes clear when this is not treated as a single rumor, but when multiple independent sources repeat the same descriptions: shiny objects, triangular, fixed positions across several orbits. If these descriptions were to be confirmed by original images, orbital data, and light analysis, they would be strong evidence against the usual explanations of optical artifacts or image noise. The big question rises: is this only the coincidence of image noise, reflections, or light scatter from Mars's surface or another known object, or is it truly a secret mission, an artificial structure, an auxiliary device of 3I Atlas, or even extraterrestrial technology monitoring the encounter? If the auxiliary object hypothesis is true, then from a strange comet, we are facing a multi-layered entity with multiple components capable of interacting with the space environment, something unlike any comet in history. If in the coming months 3I Atlas were to change its velocity by just about 10 kilometers per second, the entire scenario would shift. For an interstellar body already moving at terrifying speed, even a small deviation could turn its trajectory from a flyby into a direct impact with Mars. Such a change sounds small on paper, but in orbital mechanics, it is enough to redraw the fate of a planet. A mere nudge, whether from gravitational interactions with another body or an internal burst of gas, could be the difference between a close pass and an extinction-level event on the red planet. And it wouldn't stop there. The massive volume of material hurled into space would not remain confined to Mars. Some fragments could scatter through the solar system, turning into chaotic cosmic bullets racing along unpredictable paths. Analysts warn it is not impossible for debris to drift toward Earth's orbit, posing risks to telecommunication satellites, navigation systems, and even the International Space Station. Imagine entire swarms of rock fragments, each moving at tens of kilometers per second, creating a lethal hazard for human infrastructure in space. In the worst-case scenario, a secondary meteor storm could be triggered, not just threatening equipment, but directly endangering human lives. The consequences would not simply be the loss of equipment or infrastructure. They would strike at humanity's long-held dream of colonizing Mars. For years, Elon Musk, NASA, and other organizations have nurtured plans to send people to the red planet, but if a colossal impact crater were created, shrouded by thick dust and heightened radiation, those plans could be delayed for decades or abandoned forever. Colonization is not just about rockets and engineering. It depends on a stable environment. An atmosphere filled with fine dust and a surface scarred by radiation spikes would make Mars more hostile than ever. In this context, Harvard and NASA are not just tracking 3I Atlas's orbit, but also forced to consider preventive scenarios. Yet humanity currently has no technology powerful enough to deflect a massive object plunging in from interstellar space. Experiments like the DART mission, which struck the asteroid Dimorphos in 2022, only proved we could nudge a small body. For a mass moving at nearly 90 kilometers per second, intervention is nearly impossible. Even nuclear options that have been theorized would struggle against the sheer velocity and momentum of such an object. Thus, the impact scenario of 3I Atlas is not only a scientific problem, it is a test of human awareness. Do we have the clarity to recognize that the universe always holds dangers beyond our control? Or will we continue to ignore them until a true warning falls from the sky, burying every ambition we have built? 3I Atlas has proven that it is not just a drifting comet. What we know about it so far is like a mask that keeps falling away, revealing deeper layers of mystery that leave scientists stunned. From its rigid orbit unlike any other comet, to its strange, steady outgassing pulses, to the burst of nickel in its spectrum without any sign of iron, all of it combines to turn 3I Atlas into an astronomical riddle with no solution. Harvard and NASA have officially admitted this interstellar object must be tracked hour by hour, not only because of its potential close approach to Mars, but because of its anomalies that defy every rule of astrophysics we thought we understood. Professor Avi Loeb of Harvard has called it a phenomenon beyond the boundaries of conventional astrophysics, and that is a clear warning that 3I Atlas should not be underestimated. If the impact scenario comes true, the result will not just be a massive crater on Mars. It would be a disaster that disrupts every mission, destroys the rovers, and could hurl billions of tons of debris into space. Those fragments, analysts warn, could move far beyond Mars's orbit and even threaten Earth in the future. This is a real astronomical danger, one that forces us to consider defenses humanity does not yet possess. But beyond the physical threat lies a question far more chilling. What if 3I Atlas is truly an artificial technology disguised beneath a comet's shell? What would it mean if it struck Mars? Would it be nothing more than a random collision, or could it be a kind of message sent to humanity? Are we witnessing the first encounter with an extraterrestrial intelligence, not through radio signals or beams of light, but through its physical presence right here in our solar system? When we look up at the night sky, we like to believe the stars and planets are fixed, distant, unchanging. But the arrival of 3I Atlas is a reminder that space is never still. It can send us unexpected travelers, sometimes harmless fragments of the cosmos, but sometimes something far beyond imagination. And this time, it is no longer a science fiction story on a movie screen. It is a real possibility, unfolding right before our eyes. So what do you think? Is 3I Atlas just a cosmic coincidence, or could it be a message from a civilization no one has ever known? Leave your thoughts in the comments below and subscribe to MindGap to continue this journey into the unknown. Because sometimes the answers we seek are not written in textbooks, they are passing above us in the night sky, waiting to be decoded.